Hi, Calculus 1 students. So this is the series, Extra Examples for your midterm. However, I should say that this example is specifically for my section 18 because section 19 we covered this problem in class. That being said, if the explanations were a little bit fussy and you want to really watch that specific example again, you're more than welcome, right? It's there for everyone. So find all values of x for which the tangent line to this function is horizontal. Okay, this uses the chain rule, so you need to make sure, like it's in section 3.4. Now, horizontal tangent line. Okay, so the process is pretty much always the same. It is that you're gonna set f prime of x equal to 0 and solve for x. Okay, so we've seen that problem before, and that's it. This is what you need to do. Okay, just because the slope of the tangent line has to be 0 for the tangent line to be horizontal. And we're finding the values of x for which that happens. So that's why we're solving an equation for x. Okay, first the derivative. So this problem is harder than what you would probably think, because it involves, first of all, the derivative is not that easy, to be honest. So y prime. Okay. So the first thing is to use the product rule and then the chain rule. So I'll get the product rule out of the way because I don't want to do too much at the same time. You will do too much at the same time. You will do a lot at the same time only with practice. Okay? So 2x minus 1 to the power of 4/3 prime. So take the derivative of the first times the second. And then plus the first times the derivative of the second, right? So times like the 2 minus x to the power of 2/3. All right. So now each of these derivatives will use the chain rule. Okay, so I like color coding my chain rules. You know me, guys, at that point. So 4/3 bracket outside inside rule. So this is the derivative of the outside function. I stick the inside in. So 2x minus 1. And then take the derivative of the inside function, which turns out to be just 2. Don't forget to multiply in the rest. Okay, then we have this 2x minus 1 to the 4/3. And then there we go, 2/3. Now, don't forget, it's the outside-inside rule again. So this is the derivative of the outside. So outside, remember, it's the exponent of 2/3, pretty much. And the inside, I forgot to color code here, but that's it. Like, it's just the inside of the bracket in this case. So that's what you replace in this one bracket. And then you take the derivative of the inside, which turns out to be -1 in this particular case. Okay, now we will use a technique, okay? Because don't forget that you have to set the derivative to 0. So you have to solve this big thing for x, okay? Not easy, not easy. So here's where the technique comes into play. The technique is called simplify. Well, actually, it doesn't have a specific name. So I'll just say technique. What you're going to do is you're going to factor each of the common factors to their lowest exponent. So factor, okay, each common factor to their lowest exponent. So what do I mean by this? All right. So first of all, the numbers. Let's factor out the numbers. We can factor out a 3 here. And we can, because it's common here and here, but we can also factor the 2 that's here. That's common here and here. So in other words, 2/3 is a common factor. Let's already make it equal to 0. So that would actually be step number 2. So step number 2, we have that 0 is equal to, and I will use that step to actually factor out the 2/3. Just the number. Okay? Next, we have these common factors of 2x minus 1. There's one here and there's one here. The lowest exponent is 1/3. Okay? And here, I guess we can begin maybe... Oh, not yet. Okay, not yet. So let's take it out. We have 2x minus 1 to the 1/3. And then we have this other factor right here. And its lowest exponent is -1/3, right? Between 2/3 and -1/3. That's what we're looking for. So you have 2 minus x to the power of -1/3. Okay. Finally, we have to write what's left. Okay, so what is left after all that factoring? Let's open a big bracket. So the 4 here hasn't been factored out, so it stays in. This is completely factored out. There's no more. But now this is where it gets a little bit tricky. What you want to do is you have, and let's actually color code it as well. You have like 2 minus x to the 2/3 divided by 2 minus x to the power of -1/3. Okay, and this is because you took this out. So you need to divide this by this. Okay, now here I want to do some algebra on the side to show you what will happen so that we will save some time later. So to simplify this, what you need to do is to subtract the exponent. So you will get here 2/3 minus the -1/3, which will amount to 2 minus x to the power of 3/3, which is 1. What I want to show you is that this result was expected. Okay, so we took the lowest exponent 1, and the difference between the two exponents is 1. The reason for that is because we know how the power rule operates. Okay, so the power rule, remember, so power rule. Okay, actually, let's actually write it down underneath. This was expected since the rule x to the n prime, n times x to the power of n minus 1, it's actually decreasing the exponent by 1. Decreases the exponent by 1. And what this means is that we could have escaped this calculation because we know that this exponent is 1 less than this exponent. So now that we did it, we will use that knowledge to write the other term. Okay, so again, look at this guy. So this exponent is 4/3, this exponent is 1/3. 4/3 minus 1/3 is 3/3, that is 1. But again, you don't need to calculate it because it turns out, okay, that that this is the way the power rule operates. We know that this exponent is 1 smaller than that. Then what's left? This is fully factored, this is fully factored, and we have a -1. Oh, I'm not going to color code this one. I'm just going to write it in blue. So we do have the -1 that's left here. All right, now that we have this, I can erase the stuff that is like above. So, yep, I will even erase this, no problem. So take a step just to simplify what you have here. Okay, so in other words, you have 0, which is 2/3. Now I'm gonna stop color coding these just to because I don't want you to focus here anymore. To the negative 1/3. Then here you're gonna have 4 times 2 minus x minus 2x minus 1. Okay, now one thing that I will show you here is you would have advantage to put this at denominator. So move this to denominator. Okay, so you have 2/3, and then this is what's gonna happen. Look, you have 2x minus 1 to the 1/3, and then you're gonna end up dividing by 2 minus x to the 1/3. And this moving of it to the denominator turns out to be very important. Now, this simply, you just simplify it. So you have negative 4, negative 2x, so negative 6x, and you have 8 plus 1, so 9. This is what you get in the end. So 0 being equal to that. Now, finally, you know that this big expression will be 0 only if one of the numerators is equal to 0. So in other words, it will either happen if 2x minus 1 is equal to 0, or if negative 6x plus 9 is equal to 0. In both cases, so you have either x is equal to 1/2 or x is equal to, as I can see, 3/2. And this is your answer. All right, guys, I'm sorry. I know the video was a little bit long, but I do think it was important to spell this out properly, because when I did it with my section 19, they had trouble like with my explanation. So hopefully now it's clear cut. And if you have questions, reach out to me. Otherwise, see you in the next video.